Several students have been wondering how to rotate graphs. They want to take a parabola or an ellipse and rotate it by a certain degree and then regraph it. The concept to this is pretty simple. You have to remember these formulas right here. You have to use these formulas. The first one says x prime. X prime means the rotation of your x value. And anywhere you see an x, you're going to replace it with x cosine your angle that you're concerned with minus y sine your angle that you're concerned with. In a similar way, any y's that you see in the formula need to be replaced with x sine your angle that you want to rotate plus y cosine the angle that you want to rotate. Now, I'll give you an example and try to explain this in the best detail that I can. So, first off, let's say that you had, we'll keep it real simple. We'll say we have y equals x squared. If I have y equal x squared and I want to rotate it, say, 15 degrees. A 15-degree rotation needs to be converted into radian degrees. And so I would go 15 divided by 180 and then smack a pi on there. And so this becomes 1/12 pi, or pi over 12. At pi over 12, that's going to be the value that I replace all these thetas with. And typically we say x there, but it would be confusing because you already have x's. That's why I wrote theta here. But this is representing the angle that I want to rotate. Now, first thing before I plug anything in here, I want to explain what the rotation would do. So if I look at this y equal x squared, again, it's just that standard position of a parabola. The rotation of 15 degrees is talking about taking this graph from its line of symmetry and rotating it just 15 degrees like that. So off of this one, it would be from the north. It goes 15 degrees clockwise. And it would redraw this, pardon my artistic ability, I know it's not very good, but it rotates that 15 degrees as such. And so in order to do this, to make this reflect here, what I would do is say x times sine of pi over 12 plus y times cosine pi over 12 equal, now because I have a square here, I'm going to need some parentheses. So I put a parenthesis here, and I'm just replacing that x with all this stuff here. So it would be x times cosine pi over 12 minus y times sine of pi over 12 quantity squared. I know I wrote that kind of crunched together there, but you get the concept. I want to go on to another example and maybe go to the next level here. Let's say that I had an ellipse that looks something like this. Let's say it went up 5 units this way and 2 units that way. The equation centered at the origin would be y squared over 25. I guess I want to have my x's first. X squared over 4 plus y squared over 25 equal 1. I can replace the x and the y like I did in the previous problem with whatever angle that I want to rotate it at. So let's say I want to rotate it at 45 degrees. So if I do 45 degrees, it's going to go right along this y equal x line. It would rotate that same ellipse 45 degrees. Again, how I do that, I just put a parenthesis here. I'm going to replace the x with x times cosine pi over 4. Pi over 4 is 45 degrees. Minus y sine pi over 4. Square it, divide it by 4, and then in the very same way, I replace that y with this formula right up here. So I would say x sine pi over 4 plus y cosine pi over 4, close that out, square it, put it over 25, and then set that equal to 1. Now the next question is, well, that's fine and dandy if you're at the origin, but what happens if you want to do both a phase shift and a rotation? Or maybe you want to have your parabola at a point that's not on the origin and you want to rotate it from that vertex. Or you have an ellipse that's not on the origin, and so it's out here somewhere, and you want to take this ellipse and you want to rotate it from this center point over here. It's going to combine the two ideas. When we say combine the two ideas, let's just do something simple. Let's say that I had, well, let's stay with ellipse. Let's say that we had x plus 3 quantity squared over 9 plus y minus 2 quantity squared over 25 equal 1. If I want to rotate this, say 30 degrees, but you want to keep the center of that original ellipse, first thing you want to do is figure out what 30 degrees is. In case you forgot already, you go 30 divided by 180. Now when I do 30 divided by 180, that's going to be pi over 6. So that's the angle that I'm going to work with. It's going to be pi over 6. Everything's going to be pi over 6. And what that does is, for this particular one, we've got an ellipse that's oriented vertically. It will take that and it will rotate it 30 degrees from the north. So it takes it right here and it goes 30 degrees like that. It's not like when you do a unit circle and it measures counterclockwise. This is always clockwise. It'll go here and then rotate you. All right, so to do this, I'm going to try and write this as neat as I can here. May not be the easiest thing in the world to see, but I look at that x and I have the formula that says you want to go x times cosine pi over 6 minus y times sine pi over 6 quantity squared over 9. I'm not done yet. I'm going to change some stuff here, so just hold on. The y is going to be the same thing. I'm going to go x times sine pi over 6 plus y times cosine pi over 6 quantity squared over 25 equal 1. And then you say, well, wait a second, you didn't do any of your phase shifts up there. What happened to this plus 3 and the minus 2? As I tried to explain in the previous examples with phase shift, if you do a phase shift, it's everywhere you see an X and everywhere you see a Y that you have to reflect that phase shift. And so that's why I wrote this to begin with like this. I'm going to come back, and where I have just this plain old X, I'm going to replace it with an X plus 3. And so this becomes X plus 3 times cosine pi over 6 minus parenthesis where the y is. The y has to be replaced with a y minus 2. Y minus 2 times sine pi over 6. Parentheses around that, brackets around that. And then in a similar way, when I get to this part, I'm just replacing the x the same way I did on the previous part. I go x plus 3, this time it's sine pi over 6 plus the y gets replaced with a y minus 2 cosine pi over 6, square it, divide by 25, set it equal to 1. And essentially what that does is takes this original ellipse that was located -1, 2, 3, and up 2. It was centered like here. And so it was looking something like this. It'll take that ellipse and it'll rotate it 30 degrees. So here's your north, up, down. You go like 30 degrees there. That means here's your line of symmetry here. The new line of symmetry would look something like that, and it would create this ellipse, exact same ellipse, just rotated. Hopefully this helps you out with some of the ideas on how to rotate function, and it helps maybe enhance your drawings a little bit. Good luck to you, and remember those are due Tuesday.